Introduction to Forensic Sciences. Module 1. Forensic science is the scientific method of gathering and examining information about the past which is then used in a court of law. The definition of forensic is an argument or discussion used for a legal matter in a court of law. Therefore, forensic science is a dialogue about or debate of scientific theories in a judicial setting. Throughout the years, forensic science became more prominent in legal settings and scientific discoveries were commonly used to decide the outcome of important legal matters. Solving mysteries is a challenge many people enjoy. If they take a scientific approach, they are likely to use forensic sciences to examine evidence and solve crimes. Students are commonly exposed to crime situations in media, both fictional and real, and are likely aware that forensic sciences are used to solve crimes, as many current television programs and popular authors use the science of forensics to develop their dramas. However, students may not be aware of the methodology used by law enforcement personnel. By becoming involved in a simulated crime scene, students will see how forensic investigators apply scientific skills and processes in a problem-solving capacity. In this chapter, we shall cover the following topics: history of forensic science, overview of forensic science, types of evidences and their role in forensic investigations, forensic science and other disciplines of science. Module 2. History of forensic science. The word forensic comes from the Latin term forensis, meaning of or before the forum. The history of the term originates from Roman times, during which a criminal charge meant presenting the case before a group of public individuals in the forum. Both the person accused of the crime and the accuser would give speeches based on their sides of the story. The case would be decided in favor of the individual with the best argument and delivery. This origin is the source of the two modern usages of the word forensic, one as a form of legal evidence and as a category of public presentation. In modern use, the term forensic in the place of forensic science can be considered correct, as the term forensic is effectively a synonym for legal or related to courts. However, the term is now so closely associated with scientific field that many dictionaries include the meaning that equates the word forensics with forensic science. Although there are some examples of forensics being employed in antiquity, the idea of using science in the fight against crime didn't become popular until the late Middle Ages due to the frequency of human poisonings across Europe. Poisoning was difficult to detect because the symptoms were similar to those of many of the untreatable infectious diseases of the time. At the beginning of the 19th century, the first steps were made to demonstrate the use of poisoning by analyzing the corpse for toxic substances. Towards the end of the 19th century, the acceptance that everybody has different fingerprints made great impression on the detection of the crime, as did the discovery that people have different blood groups, so that blood stains left at the scene or found on an injured party could be linked to a suspect. Forensic science has been greatly popularized by authors such as Sir Arthur Conan Doyle through his infamous character Sherlock Holmes, and through many contemporary TV series such as CSI, Dexter and Bones. It has also created unrealistic expectations from forensic science known now as the CSI effect. The history of forensic science dates back thousands of years. Fingerprinting was one of its first applications. The ancient Chinese used fingerprints to identify business documents. In 1892, an eugenicist who is an adherent of the often prejudiced system of scientific classification named Sir Francis Galton established the first system for classifying fingerprints. Sir Edward Henry, Commissioner of the Metropolitan Police of London, developed his own system in 1896 based on the direction, flow, pattern and other characteristics in the fingerprints. The Henry classification system became the standard for criminal fingerprinting techniques worldwide. In 1835, Scotland Yard's Henry Goddard became the first person to use physical analysis to connect a bullet to the murder weapon. Bullet examination became more precise in the 1920s when American physician Calvin Goddard created the comparison microscope to help determine which bullets came from which shell casings. And in the 1970s, a team of scientists at the Aerospace Corporation in California developed a method for detecting gunshot residue using scanning electron microscopes. In 1836, a Scottish chemist named James Marsh developed a chemical test to detect arsenic, which was used during a murder trial. Nearly a century later, in 1930, scientist Carl Landsteiner won the Nobel Prize for classifying human blood into various groups. His work paved the way for future use of blood in criminal investigations. Other tests were developed in the mid-1900s to analyze saliva, semen and other body fluids as well as to make blood tests more precise. With all of the new forensic techniques emerging in the early 20th century, law enforcement discovered that it needed a specialized team to analyze evidence found at the crime scenes. To that end, Edmond Locard, a professor at University of Lyon, set up the first police crime laboratory in France in 1910. For his pioneering work in forensic criminology, Locard was known as Sherlock Holmes of France. Auguste Vermer, chief of the Los Angeles Police, established the first American police crime laboratory in 1924. When the Federal Bureau of Investigation (FBI) was first founded in 1908, it didn't have its own forensic crime laboratory that wasn't set up until 1932. By the close of the 20th century, forensic scientists had a wealth of high-tech tools at their disposal for analyzing evidence from polymerase chain reaction (PCR) for DNA analysis to digital fingerprinting techniques with computer search capabilities. Module 3: Overview of Forensic Science. Forensic science is the application of science to law. To simplify, we can say that it is the application of science to those criminal and civil laws that are enforced by police agencies in a criminal justice system. A forensic team is a group of scientists who work together performing different jobs to solve crimes or to identify people. A forensic team may observe the crime scene and gather evidence such as hair and fiber samples, fingerprints and tissue samples. An investigative team includes forensic scientists with varying areas of expertise including toxicology, forensic biology, forensic entomology, chemistry, forensic psychology, forensic odontology, forensic anthropology, bloodstain pattern analysis, and weapons specialists. The job of forensic investigators is to use science and technology and to perform tests on the evidence collected. The results from these tests can then be used to support a theory of guilt or innocence. Forensic scientists use the same instruments and techniques used by scientists doing other types of research, including microscopes, computers, gas chromatographs, and lasers. As science is advanced, so it has the ability to gather evidence and solve crimes. At crime scenes, portable lasers provide special lighting. Imaging technology lets a police officer instantly send photograph or fingerprint image to a central data bank for identification. Computers can enhance pictures taken by a security camera at crime scene. New chemicals allow the visualization of otherwise unseen fingerprints. Lasers can vaporize tiny portions of paint specimen to determine the exact paint used on a car in a hit and run case. A single cell can provide deoxyribonucleic acid, the DNA, that molecular biology techniques can match with a suspect. Forensic scientist. Forensic scientist is the person who performs investigatory examinations and laboratory tests to reach a conclusion for a crime scene investigation and lab analysis. He is a communicator and interpreter of those findings. He must be able to explain the methods used to reach that conclusion in a court of law. He must provide report results, oral and or written, under court testimony. Forensic lab safety. The job of a forensic scientist involves using a variety of chemicals which can be flammable, corrosive and even explosive if not handled properly. Here are a few tips that forensic labs follow to ensure that their employees stay safe. Labs should have procedures in place for the use and disposal of chemicals as well as a safety plan in case of emergency, including a safety shower and eye wash station. Employees need to be well trained in the use of all chemicals, understanding the properties of each chemical and its potential to cause injury. Lab technicians should wear the proper gear, eyewear to protect against chemical splashes and gloves to protect their hands. Chemical containers should be properly labeled with correct chemical name. Flammable liquids should always be kept in special storage containers or storage room. Putting these type of chemicals in a regular refrigerator can lead to an explosion. Module 4. Types of evidences and their role in forensic investigations. As per Lockhart's exchange principle, when a criminal comes into contact with an object or person, a cross transfer of evidence occurs. Wherever he steps, whatever he touches, whatever he leaves, even unconsciously, will serve as a silent evidence against him. Not only his fingerprints or his shoe prints, but also his hair, the fibers from his clothes, the glass he breaks, the tool marks he leaves, the paint he scratches, the blood or semen he deposits or collects, all these and more bear mute witness against him. This is evidence that does not forget. It is not confused by the excitement of the moment. It is not absent because human witness are. It is factual evidence. Physical evidence cannot be wrong. It cannot perjure itself. It cannot wholly be absent. Only in its interpretation there can be error. Types of evidences: bite mark, blood and body fluids, bones, broken fingernails, that is striations, drugs, explosives, fiber, fingerprints, firearm powder residues, firearms and tool marks, glass, hair, ink, paint, petroleum products, questioned documents, shoe prints and tire tracks, soil and minerals, teeth, toxicology. Let us see few of the examples of evidences. Fingerprints examination. Fingerprint is friction skin located on the fingers of the palm side of the hand from the first joint to the nail bed, areas of skin bearing ridges and furrows, corrugated skin on the volar areas of the skin specialized for traction. Types. Following are different types of fingerprints. Loops. One or more ridges entering from one side of the print, recurving and exiting from the same side. Ulnar. Opens towards the little finger. Radial. Opens towards the thumb. Holes. Enters from both sides and ridge flow, that is circular in nature, divided into 4 distinct groups. Arches. Ridges that enter on one side and flow or tend to flow out the other with a rise in the center, divided into 2 distinct groups. Fingerprint individual characteristics. Details within the ridge flow that represent a unique occurrence, that is type, relative location, orientation and number. Ending ridge. A ridge that follows a distinct path and ends abruptly. Bifurcation. Ridge that follows a distinct path and divides into 2 ridges. Dot. A ridge unit that is as long as it is wide. Scientific basis. Fingerprints can be used for individualization because they are unique and permanent. Uniqueness. No 2 individuals or 2 fingers from the same hand share the exact friction ridge detail. In over 100 years of billions of friction ridge comparisons, no one has yet to find 2 areas of friction skin from different sources with same ridge configuration. Permanence. During fetal development, friction ridges are formed and are permanent throughout life until death and decomposition, except in instances of permanent scarring or amputation. Firearms examinations. A bullet is impressed with rifle markings of the barrel when it emerges from the weapon. Some of the evidences under firearms examinations are discussed as follows. Fired bullets, general characteristics such as caliber, physical features of rifling impressions, manufacturer of bullets, cartridge cases or shot shell casings, caliber or gauge, presence of marks for comparison, shot pellets, buckshot slugs, size of shot, gauge of slug, weighting. Components can determine gauge and manufacturer. Gunshot residue, indication of holding firing weapon, chemical components, shot pattern, type of gun, distance from muzzle, bullet and casing matched back to gun, that is ejector, firing pin, breech block and extra extract or marks matched back to same lot of ammunition found in suspect's possession. Latent prints. Generic term used to describe any evidentiary print recovered from a crime scene. Some of the examples are as follows. The unintentional recording of a friction-rich skin. A reproduction of the friction-rich skin information left on an object when touched. The transfer of material from a surface to the friction-rich skin. Types of evidentiary prints. Latent, invisible. Rich impressions caused by the transfer of body perspiration or oils to the surface of an object requiring development or enhancement for their visualization. Patent, visible. Ridge detail transferred to a surface after the ridges have been in contact with a colored material such as blood, paint, grease or ink. Plastic impression. Ridge impressions left on a soft material such as putty, wax, soap or dust. Exemplar prints. It is the intentional recording of friction-rich skin from a known individual in a controlled environment for documentation, classification or comparison. Few examples of exemplar prints are as follows. Form collection, 10 print card, major records, postmortem prints, examples of collection, arrest, military record, job requirement and driver's license. Module 5. Forensic science and other disciplines of science. As students explore the topic of forensic sciences, many sciences may naturally be integrated. It is important to recognize and reinforce with students that it is common for diverse specialties to operate simultaneously in scientific investigation. Let us see what are they. Art forensics concerns the art authentication cases to help research the work's authenticity. Art authentication methods are used to detect and identify forgery, faking and copying of artworks, example paintings. Computational forensics concerns the development of algorithms and software to assist forensic examination. Criminalistics is the application of various sciences to answer the questions relating to examination and comparison of biological evidence, trace evidence, impression evidence such as fingerprints, footwear impressions and tire tracks, controlled substances, ballistics, firearm and tool mark examination and other evidence in criminal investigations. In typical circumstances, evidence is processed in a crime lab. Digital forensics is the application of proven scientific methods and techniques in order to recover data from electronic digital media. Digital forensic specialists work in the field as well as in the lab. Forensic accounting is the study and interpretation of accounting evidence. Forensic aerial photography is the study and interpretation of aerial photographic evidence. Forensic anthropology is application of physical anthropology in a legal setting, usually for the recovery and identification of skeletonized human remains. Forensic archaeology is the application of combination of archaeological techniques and forensic science, typically in law enforcement. Forensic astronomy uses methods from astronomy to determine past celestial constellations for forensic purposes. Forensic botany is the study of plant life in order to gain information regarding possible crimes. Forensic chemistry is the study of detection and identification of illicit drugs, accelerants used in arson cases, explosive and gunshot residue. Forensic dactyloscopy is the study of fingerprints. Forensic document examination or questioned document examination answers questions about a disputed document using a variety of scientific processes and methods. Many examinations involve a comparison of the questioned document or components of the document with a set of known standards. The most common type of examination involves handwriting, whereby the examiner tries to address concerns about potential authorship. Forensic DNA analysis takes advantage of the uniqueness of an individual's DNA to answer forensic questions such as paternity maternity testing and placing a suspect at a crime scene, example in a rape investigation. Forensic engineering is scientific examination and analysis of structures and products relating to their failure or cause of damage. Forensic entomology deals with the examination of insects in, on and around human remains to assist in determination of time or location of death. It is also possible to determine if the body was moved after death using entomology. Forensic geology deals with the trace evidence in the form of soils, minerals and petroleum. Forensic geophysics is the application of geophysical techniques such as radar for detecting objects hidden underground or underwater. Forensic intelligence process starts with the collection of data and ends with the integration of results into the analysis of crimes under investigation. Forensic interviews are conducted using the science of professionally using expertise to conduct a variety of investigative interviews with the victims, witnesses, suspects or other sources to determine the facts regarding the suspicions, allegations or specific incidents in either public or private sector settings. Forensic limnology is the analysis of evidence collected from crime scenes in or around freshwater sources. Examination of biological organisms, in particular diatoms, can be useful in connecting suspects with victims. Forensic linguistics deals with the issues in the legal system that requires linguistic expertise. Forensic meteorology is a site-specific analysis of past weather conditions for a point of loss. Forensic odontology is the study of uniqueness of dentition, better known as study of teeth. Forensic optometry is the study of glasses and other eyewear relating to crime scenes and criminal investigations. Forensic pathology is a field in which the principles of medicine and pathology are applied to determine a cause of death or injury in the context of legal inquiry. Forensic podiatry is an application of the study of feet, footprint or footwear and their traces to analyze scene of crime and to establish personal identity in forensic examinations. Forensic psychiatry is a specialized branch of psychiatry as applied to and based on scientific criminology. Forensic psychology is the study of the mind of an individual using forensic methods. Usually, it determines the circumstances behind a criminal's behavior. Forensic seismology is the study of techniques to distinguish the seismic signals generated by underground nuclear explosions from those generated by earthquakes. Forensic serology is the study of body fluids. Forensic social work is the specialist study of social work theories and their applications to a clinical, criminal justice or psychiatric setting. Practitioners of forensic social work connected with the criminal justice system are often termed social supervisors, while the remaining use the interchangeable titles forensic social worker, approved mental health professional, or forensic practitioner, and they conduct specialist assessments of risk, care planning, and act as an officer of the court. Forensic toxicology is the study of the effect of drugs and poisons in the human body. Forensic video analysis is the scientific examination, comparison, and evaluation of video in legal matters. Mobile device forensics is the scientific examination and evaluation of evidence found in mobile phones, example, call history and deleted SMSs, and includes SIM card forensics. Trace evidence analysis is the analysis and comparison of trace evidence including glass, paint, fibers and hairs, example, using microspectrophotometers. Wildlife forensic science applies a range of scientific disciplines to legal cases involving non-human biological evidence to solve crimes such as poaching, animal abuse, and trade in endangered species. Blood spatter analysis is the scientific examination of blood spatter patterns found at a crime scene to reconstruct the events of the crime. Forensic investigation, also known as forensic audit, as it is the examination of documents and the interviewing of the people to extract evidence. Forensic investigation is fast emerging as a lucrative professional practice field. With increased sophistication of white-collar criminals, there is a demand for well-trained experts to carry out investigations and also institute preventive, deterrence and detective measures.